Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 276, maximum running time of N computers. I struggled a lot with this one. I think a lot of people are very smart or something. So for this one, it's very tricky for me. I also want to say that for this particular problem, there are many different ways to solve, or maybe not many, but there are at least a couple of ways to solve it. And I want to go over all the solutions, which is why this video is a little bit later than do have it usually. So yeah, so definitely hit the like button. Please hit the subscribe button and join me on Discord. Just come over Discord and just, show me some love, just so that, let me know my efforts are worth it, because this was a very tough contest. I finished at 443, and I finished Q3 really quickly. So I spent almost an hour on this one. I think, and before I get into this, my videos, if you're new to this and you might not know, but the way that I structure my video is to kind of explain my thought process and going through the struggles and stuff like that, because there are probably a lot of videos on explanation alone, and you could just check them out. I want to show you that, I used to be top 100 on Leetcode, or even I think I was highest, like top 40 on Leetcode, like overall. Though I think I dropped a little bit recently. Yikes! But yeah, someone like that, someone like me, can still struggle from time to time. So definitely. But that said, right, don't give up. I took an hour to do this, but which is, yes, I took an hour to do this, but that also means that I did not give up after an hour. You've been seeing hundreds of people getting it, right? So I didn't rage quit. I didn't, give up. So I want, just put that in mind. Okay. So for this one, just to set a little bit context, my struggle is, to be honest, I think I did a similar problem to this one, where the answer involved a heap, to be honest. And I think from that, I don't know how long it is. Maybe you could check out, I'll have the live, me live solving this in the portion below, afterwards, so you can fast forward to that if you like. And if you do watch that, I probably urge you to watch it on a faster speed, but yeah, the idea is that yeah, I think I was just stuck mentally, to be honest, and that's where I get in trouble from time to time, because it took me a long time to kind of refresh and then try to start, not from the beginning per se, but start again with the visualization and the mentality and stuff. And I think one thing that I want to say about this particular problem is one thing I want to say about this particular problem is that there is some it is a way visualization. It is a problem that I think, to me, requires visualization, and definitely you should get out pen and paper. I definitely had a lot of pen and paper, but it didn't really help enough. I actually implemented the very naive heap solution, and you could see that when I solved it live, and to kind of help with the visualization, until I kind of play around with it until I was like, oh wait, I could try this thing. And actually, to be honest, even though I had that, I did not really come to my final solution, even though I had and my solution that I submit was correct, and yeah, but it was still very yucky compared to a lot of the shorter code that you might have seen. That said, I will help you. I'll show you my visualization, and one thing that happens to me is that sometimes I find it hard, because this part of this problem is going to be greedy. Maybe not greedy in an optimization kind of way, but greedily use these batteries in an interchangeable kind of way. Maybe that's one way to say it. And what I mean by that is that, yeah, so let's say you're using some N batteries, you can actually just end up adding capacity. And okay, maybe that's actually not a great explanation, but let me put out let me put out paint so I could draw out what I mean, right? Give me a second. Nope, that's the wrong button. Okay. So yeah, so let's say now you have something like, let's say k is equal to 3, or sorry, not k is equal to 3, n is equal to 3, and you have like all these boxes. And first of all, let's just say we start sorting them, right? And in a greedy kind of way, of course, let's say k is equal to 3, so let's say that we are going to use red or green, this is, or whatever this color is, right? And then now then the idea is that we take all these other numbers or other capacity and then put them on top as much as we can. And that's basically my solution, even though it took a long time to come to this, is that, okay, let's say we greedy always take the top n because we set them on the basis, and let's say if we don't add any more capacity, then this is going to be our answer, right? This height, it's going to be our answer if we don't add anything. Of course, we get to add stuff, and that's basically the idea, is that we do in a greedy way. Let's say we have this box, we can greedily, let's say we have this box, we could greedily add it here. Let's say we have this box now, we can maybe add half here and half here, right? That's basic. And then now, after you kind of take all these extra boxes and add them more, basically the maximum height is going to be the height of the smallest thing. And that's basically my idea that I have, and I implement it in a couple of ways. So let me show you the code that I submitted, and that's basically the idea though. Yeah, hopefully that makes sense though, is that we use all these extra capacity, and then, but in this case, we split in half because they're two, in a greedy way, you kind of split them into two things. Yeah. Oh, let me get rid of this real quick. And that's basically my code. Oh, this is not that version of my code. Let me see. Yeah, this is the first iteration that I did, which is that, okay, so we sort and we reverse. So then now we have, actually what I did is I implement this using a stack, and basically I have in the current stack, I count the height of the battery. I call it the height, but it basically is like the capacity of the battery and the number of count, right? And of course, if they're multiple, I just merge them into one. And then here, now for every new battery after that, I have leftover capacity, which you can think about it in a different way. But basically now, here at one at a time. Oh, I didn't remove this, so hang on. Oh, I guess it wasn't blocking, so I was very fortunate. But yeah, one at a time, I go, okay, let's say delta is the gap. So actually, let me bring that back up real quick. So let's say that means that for this particular piece, delta is just this portion, right? So then that means that this is how many, and there's one count, there's one width that we're adding. Let's say initially we're adding this box, we have one width we added here. And then if we have leftover, we have leftover. And then now let's say we're into the second box, or the first box on the left. Now the width is going to be 2, because now we're considering these two, because now we merge them together. And then now we just basically also merge them at half height. And that's basically the idea behind this code. It's very long compared to what you'll see later. It's very yucky, but this is me without really understanding the problem to a degree that some of these other solutions have, right? But yeah, so basically I do this. I go, okay, so this delta is the max that we can increase, where count is the width of, or how many computers you're increasing at the same time. And this is just the numbers that changed. I added to the change. If it changes 0, then we set everything to leftover, and then we break because this is no longer changing. Otherwise, we subtract it from the battery that we have now, which is added by leftover. And then once we add that, this is just to kind of merge them together, right? So that if you have two columns of the same height, you merge them to one column with a wider, one column counting two batteries, right? And then at the end, if there's only one battery height left, you just kind of put everything in that one battery, and that's it. Yeah. And then at the very end, like we said, this is just going to be the last height that we have, because that's the limiting factor of this problem, right? Cool. Yeah. Whoops, almost quit this thing. Cool. Yeah, so that's one solution. And then one observation that I would say, and I did test this afterwards, is that actually you don't need to do this stuff on the left. Let me change the color a little bit, it's getting crazy. Okay, this stuff on the left, this orange stuff, we don't actually need to do this one at a time, because we can just combine them into extra capacity, because, now, if you think about it, addition is distributed, it's commutative, whatever, right? So that means that now we can add all these into one giant box. Let's say we have these two boxes. We actually have to, we can add this to here, right? Now we have one giant box. I think this is very messy, but okay, let me change the color again to blue. Okay, fine. So then now we add this box into this box to get this box, and then the idea is that process this. Now that we have this box, we process adding it to here, and then here, and then so forth, ... right? So that's basically this solution. This is my second solution, where basically, as you can see, it's simplified a little bit. Instead of this code, which is the same as I had before, instead of that being inside the loop, we just basically sum up all the batteries, and then we want this stack-based thing of filling it up. I think about this almost like similar to like rainwater or something like that, where you're basically filling up from the smallest capacity up, right? Like in a greedy way, you're filling up the smallest battery up from capacity. So that's the way that I would think about it for this one. That's the way that I implement it. But I would say, to be honest, this is very hard, very messy, but I got it. I'm happy about it, even though it took an hour, where it took people like 4 minutes or something like that. And this is not even a top score. So yeah. And then now, yeah, I'm gonna go with the binary search solution. A couple of people did it with binary search. I'm gonna do it. This solution is from Ush1729. Give him some love. Give him some, hit up his YouTube channel and look at it. I'm going to go over this idea really quickly. And once I go over the idea, this code is actually, this code is fine. But I'm just saying that, like once you get that idea, like the code doesn't really matter. It's just about the concept, right? It's binary search. And the idea here is that, the idea behind this code is okay, right? Oh, I was wondering if this sum was necessary, but it's just part of the binary search. That's why. But basically now the question is, okay, let me redraw this real quick. But I think this also builds off a property that I did not really understand, to be honest, which is that all battery capacity is interchangeable as long as you have enough. Kind of. Right? In a way. The only reason, I don't know if that's quite the right way to say it, but yeah, but let's say we have, same boxes as before. I mean, it is a little bit different, and we sorted it. Did we sort it? Actually, we don't need to sort it, but for my purposes, we'll just sort it anyway. Right. So now we have some boxes, and let's say we have a really fat one, which maybe two fat ones, right? And let's just say k is equal to 3 again, right? But this probably doesn't matter, right? Because now we're asking ourselves, using the same kind of principle of, okay, can we solve this in X time for some X, right? And this is binary search, of course, but and the binary search I'm not going to go over too deeply, to suffice to say, if you could solve it in x time, that means that you could solve it in, oh sorry, if you can have battery that lasts x, that means that you have battery that lasts x minus 1, x minus 2, and all the way, right? And then if you cannot solve it in x times, that means that x plus 1, x plus 2, those are all invalid times, right? So that's basically the idea behind binary search. Again, for the purpose of this video, I'm not going over binary search because that's a more fundamental algorithm, and definitely practice that and go over videos that I might have on that one. But the idea is that, okay, let's say that initially we try some number x, right? Let's say this is x. Well, the idea is that, okay, in x time, what can we do, right? In x time, let's say we have k is equal to 3 again, for purpose of whatever, right? The idea is that, let's say k is equal to 3. Let's say we're looking at, let me use another card really quick. Let's say we're just looking at these 3, right? These 3. And then, of course, because we only have given x time, everything over x time we don't care about, right? And then now, that means that everything that's not in 3, we basically power on. So we have all these things, we can put it into, it's the same idea as before, really, that I have, but implemented in a much easier way, is that we have all these extra capacity, we could add it to here, and again, we only need to get up to x, right? And of course, there are different ways to visualize this, but this is just like a visualization of, okay, can this be x, right? And of course, the easier way to visualize this is that, let me use another color, is that, given that we know what the k is, right? Because this is k. We know what the k is, and we know what the x is for the height, right? This is the height, right? So that means that the area here is going to be k times x, right? And then the question is, if, like we said, there is some like interchangeable property that I did not understand, which is why it took so long. Or maybe I think it is greedy in a way, and that's why I didn't really figure out how to prove. But yeah, but now if we're able to kind of take all these extra capacity and then put it in such that we have k times x, then that means that we can last until x time, right? And that's basically the idea behind all these binary search problems, is that we can use these extra capacity by moving this into, let's say, the core batteries, and then use them interchangeably, right? They're fungible, if you will. If you're playing around with fungible or non-fungible is a pretty popular word these days. So yeah, so you could kind of think about these batteries about fungible, and also in this case, now you don't have to worry about this this Tor cases, because we don't care about them anyway, right? And that's how you basically do binary search. So that's another solutions that you can do. Yeah. And then now, oh, I didn't give attribution. So this is Josh's solution, or sorry, I think it goes to numbers solution. Also, check him out on his YouTube channel. I actually don't know if he brands it with numbers or Josh, but anyway, you could find it by Googling stuff. So yeah, definitely check his out. The idea here behind his solution, and very easy solution, is the same idea that we kind of talked about, even though it's a little bit of it is a little bit different. Again, let me reset these boxes really quickly. Maybe I should have written it out, but yeah. But he sorts and reverse, and there is some prefix something. But here the idea is that yeah, once again, let's say we have these boxes. The prefix sum is just basically the sum of this box, and then the sum, the way that let me change the color real quick. Oops. the way that I think about these prefix sum is that you just have, well, in this case, you have sum of this box, you have sum of this box, you have sum of this box, and sum of this box, and so forth, right? And in this case, again, let's just say k is equal to 3, right? Then in this case, what he's trying to do is that, okay, yeah. The idea here is that, okay, first of all, let's put all these boxes. So prefix of I is actually all these things, right? So then we put it all into here. And then we try again putting all these boxes into these two, right? It's kind of that same idea. And then the idea is that, okay, given that, what would be the limiting factor in like if we did it this way with 2 batteries, yeah. And this one, I think it's a little bit, for me, to be honest, check out his channel for maybe a deeper explanation, but I kind of see it in the same way, in that and his for loops are, I think, for me, a little bit confusing to understand. But then if you write it another way, the min is kind of actually, because you can think about this as, because this function is literally the average, right? Another way of thinking about this function is that this is the average of the first x numbers, right? Or maybe not x, for the first I numbers, right? Almost, maybe not. But the idea is that maybe it's a little bit different, to be honest. Maybe I'm messing them up. But the idea is that, okay, so now you take these 3, you add it to here. How far can you get up, right? Because now is that the limiting factor, right? And this is the total of all these 3 things, right? And then now, and then the next step after that is taking these 4 numbers. Wait, maybe I'm explaining this wrong. Sorry. I think I confused myself. This one is very tricky, so I think I confused myself a little bit. Also because he does a double reversal thing, so I'm a little bit confused, but maybe not so much. Oh yeah, okay. Yeah, okay, fine. But basically, first he takes all these things, and then and then divides it by the n is equal to 5, right? Or I call it k. Sorry. So yeah, I think maybe I confused myself with the n and the k. But yeah, n is equal to 3, right? So then now first he takes all these numbers and then divide it by 3, and then he takes all these numbers and then divide it by 2. And then take all these numbers divided by 1, right? So, so then the idea here is actually, at least for me, my visualization, this is not George's explanation, because I think he keeps on trying to, and I applaud him for doing this, but I'm not trying to. I hope I don't sound like I'm dissing on him, but I think for me, I just have trouble understanding it. But the idea is that, okay, like I said, first of all, he takes all the sum of everything and then divide it by 3, right? And what that means is that basically now divided by 3 is just, and this is actually even, so this divides by 3, and then so that you get some number, right? Some level. I'm going to draw this level in another color. So you get some level, right? And then now, he takes the rest of these numbers. Oh, yikes. He takes the rest of these numbers and do it by 2. Almost like, so then now, it's and then you get another, function that, or you get another number that looks like, I guess that's actually not possible. I guess it could be possible. Yeah. Let's say you get this number after taking the first all of the numbers divided by 3, and then now you take all the other numbers divided by 2, and of course it's going to be a smaller number because, you know, and maybe, right? And then you take another number, and then you do it by 1, which is, yeah, which could be like say here, and then you have like this is number, I don't know, something like that, right? And then here you can see that his explanation is that this is the limiting factor, is that if you this is the explanation for if I put all these numbers or all these boxes and then put it inside here, what would be the minimum, right? And then it will be the minimum of all these things would be the minimum, because that is the limiting factor in solving this, because the assumption is that everything, let's say we're looking at this one, or maybe this one is the min, so let's say we're looking at this one, because we assume that everything to the right of it, it's already higher than this number, right? So yeah, yeah, and that's basically how this solution works, is that it tries to kind of figure out where to put the extra capacity, and then yeah, he actually, if you listen to that's my attempt at visualizing it. I think if you actually look at his solution, or sorry, his explanation, he has a way more mathematical explanation, but which for me, maybe I'm not as strong in the maths of these kind of arithmetic, mental gymnastics to kind of deal with it. So yeah, let me know what you think. I actually don't think I talked about complexity actually. So let me go back real quick. That's my bad. But yeah, but they're all. So for my solution, both my solutions, it's going to be linear time, because basically every number I push or pop off the stack once, so that's going to be linear time. And in terms of space, because this is linear time plus the sorting, so it's going to be n log n. And of course, because of a stack and in place sort, this is going to be linear space. So this is actually, and both these solutions have the similar thing, but yeah, time over n space. For binary search, this is actually O of n log u time, where u is the size of the universe, which is let's say 10 to the 9 times 10 to the 5th, something like that. But log of that, so it's still going to be fast enough apparently, especially. Yeah. And in terms of space, this is n. Yeah, because this is just you have O of u number of iterations for this binary search, and each of them takes O of n time. And then in terms of space, this is actually O of 1 space. I lied on this one. You could, yeah, because all you do is keep on adding stuff for this one. So yeah. And then for George's solution, this is also easy to kind of analyze. You have this linear space for prefix sum or suffix sum or whatever you want to call it. And then in terms of complexity, this is just a sorting and a for loop. So this is n log n for the sort, right? Yeah. That's pretty much all I have for this one. Let me know what you think. This is a very hard solution for me. But there are different ways to think about it. I think the easiest one, if you ask me, is probably the binary search. Though, like I said, it requires this kind of weird greedy thing that I did not get during the contest. So that's why I was so slow. But yeah, let me know what you think. And you could watch me solve it live during the contest next, though I would say maybe fast forward or watch it on the fastest speed, because it is very long. And I tried a lot of different things, and it took me a long time to really come up with the visualization until it made sense. So yeah. Anyway, that's all I have, and you can watch me solve it live next. It should be right. Wow, people are done already. Yikes. I spent too long on that one. feel like I've solved this one before in a different wording, but I forget what it is, so I guess that's not very helpful. We don't remember how to do it. I remember the silly one, but with heaps, but let's see. Actually, maybe this is a little different. Okay. There's so many batteries, so then and this is just does greedy work? I guess so. No, I guess not. Supposed to take the max. I feel like this is a known problem, but I just don't know it. think I have an idea. Maybe not. I think the case that I'm thinking of is with 2 n is equal to 2. And that's when you do a heap, but then you do a skip thingy. A lot of people are getting it. I am not getting it today, maybe. I spent 10 minutes not knowing what to do about this one, other than the naive heap solution, but that's not going to cut it with 10 to the 9. Also, I don't know how to do it with n anyway. Man, I'm really blind today. I don't know. I'm just not really seeing it today. Like I don't know how to generalize it. Yeah, I just don't know how to do this one, I guess. I don't know. This is yikes. People did it very quickly too. So I guess it's just a known thing that I don't know. Maybe it's a tank. Focus light. I don't even know how to do it for n equals 2, to be honest. Am I misunderstanding? Oh, no, you just keep on. I don't. I don't know, built in like 3 minutes. I just don't know this one. I know that I've done this problem for binary search for 2, but I don't know. I can't remember what it was. That was so long ago. Yeah, maybe I just have no idea. Maybe what happens when n is squared? That does make it one number easier, but it didn't really help enough. How do you do this thing? Maybe I should have implemented a naive one just to kind of see how it goes. I don't know how to do this one. Maybe I missed. No, I mean, this is. I don't think I missed anything, right? Yeah, my mind is not working today. I don't know. I'm out of ideas for so long. Yeah. I mean, this is right, but I don't know. I wrote this because I know it's not going to be right. But let's see. That's going to be 100. Trying to see if I could find any pattern. Can I combine numbers? I don't think so, because if I have something like this, how do that's only even in the cleanest case, right? That's enough to make it weird. I don't know how to. This is just one I'm blind to today. Because the min almost doesn't matter. I mean, there could be like an extra 1 or 2. And it wouldn't really change anything. These get used at the very end. That was so fast, and now I'm like, just have no idea how to do it correctly. Like even playing around with these examples, I don't know. Don't know that I see any idea. Only went 124 for it, which I know this is true, correct, but can I binary search on the answer? Don't think so. How do I handle the extra long case? 3, want to add this. Maybe I could think about it backwards. Maybe that's what I was missing. So 3, we added to this 3, so that's 6. 106. This is 3. What happens? We add this 3 to this 3, so it's 6. Maybe this is some idea like this. Maybe I was thinking about it the awkward way. And then my weird long answer of then what happens when you have this 102? But is there a reason why this is 102? We add 1 to 1, 1 to 1. And over 5, we want to spread that out. I think I see it now, but I'm way too slow on this one. Okay, fine. Okay, I think I see it now. Yikes. This math is hard. I think I got shadowed a little bit by okay, I think I know how to do it, but maybe. I don't know if that's true. But we'll see. And there's a number of machines. So actually what I want is okay. And then now we have battery sub I that we want to fill on the stack. Okay. Okay. If length of current is greater 2, then del2. Class number. Okay, and then now what we want is to now was that right? Okay, del2. Now what we want now is just count these del2 of these, right? So that's how many times we can go up. Okay, and now just to change some count. If now we pop it and then go. I should have kept the answer so I could have a comparison. But in here I forgot to subtract. And this is just clearly not right, so oh, right. So it's still wrong, but I think I have the right idea, maybe? Oh, I don't, this isn't combined. It's still wrong even for number 1, so that's not good. Whoops. No, this is 2. No. Okay, that's good. And how did this messed up? They should put in 1s, right? Oh, whoops. I guess no, that's not true. So that's good that this is here. Oh, whoops, that's just not right. Whoops. Okay, that's not as good. Oh, this is wrong. This is okay. Have a time limit exceeded somewhere? Oh, well, output it exceeded. Or maybe it's the same thing. Because this basically is saying that So we've changed this equals else we don't have enough. Okay, so that's why. I've changed this equal to 0, then that's not right. But we're making progress, but it's not right. Okay, so I think something messed up here anyway, but what has happened? Huh? Oh, no, this is right. But then we messed up somewhere here. I guess it's this thing. We wanted to add 5. 2, 4. This is just weird, actually. Oh, whoops. This is not right. Is 103 right? Don't know. I think this leftover is weird. Is this 103? I don't know. Let's see. 1111. No, it should be 102. Okay. And 1 left over. Same thing. I don't burn the leftover, I think that's why. I mean, I deserve this one actually. I think I should have done better about this. But at least let's make this right first too, and Oh, this is just input again. Why do I have to do input multiple times? I don't know. All right, I don't know. Let's just give it a submit. Thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem. How do you think I solved it? How did you solve it? Just come to Discord and chat about anything. There's enough people and everyone is smart. So yeah. Anyway, that's all I have. Give me some love because this was a terrible contest. But stay good, stay healthy, to good mental health, and I'll see you later. Bye bye.